Hi there, this is the second part then of the revision exercise. The first part we just dealt really, other than the very first example which I did, the one you can see on the screen, the rest of it was really just transformations and we didn't really deal with any of the modulus function stuff. So here's a go at this modulus function and making sure you're able to do questions likely to come your way in a year's time. So let's have a go at this first one. It's a solve one and also a transformation one, so almost perfect in many ways. So solve the inequality. Mod x minus 2 is less than or equal to mod of 2x minus 6. So you will recall hopefully that I've said on these questions, if it was me, I would square both sides. Because there's a modulus function on each side, square both sides. So that gives me, and then I can lose the modulus function. So I get x squared minus 4x plus 4. I don't know why I did that. I also, it's an inequality, so yeah, I'm going to stick with the equals. And this will tell me the points of intersection. I'll need to think about what the graphs look like. I'll come back to that in a bit. So let's find the points of intersection. 2x minus 6 gives me 4x squared minus 24x plus 36. Hopefully you're good at those now. I'm going to move everything over to the right hand side. That gives me 3x squared minus 20x plus 32, and that's equal to 0. So if I chuck that into my calculator, menu A, polynomial degree 2. So what have I got? I've got 3, I've got minus 20, and of course you could solve these properly, but it's quicker not to. What have I got? Okay, the first answer is 4. So I've got x equals 4 and x equals 8/3. So that's the points of intersection of the two lines. Let's see what these graphs should look like. Well, x minus 2 is the graph that does that, and I'm going to do it there because we know the modulus of it will bounce back and it will hit at 2. So that's that one done with. That's the modulus of x minus 2. That's the left hand side. What's the right hand side look like? Well, it's a steeper gradient. It also hits lower down. So minus 6 is down there somewhere with a steeper gradient. Actually, if you think about it, when would that equal 0? 2x would equal 6. X would equal 3 if I ignored everything. So I know that that's where it hits. So it does that on quite a steep gradient and does that. So that's the 2x minus 6. The modulus part of it, of course, means it bounces back. So when is the x minus 2 lower than the 2x minus 6? And it's definitely there onward. You can see the x minus 2 is lower than the other graph. And the x minus 2, oh right, from here onwards, it will always be lower, I think. That's a steeper graph, so it will never ever. So I think, therefore, x is greater than or equal to 4, or x is less than or equal to, yes, 8/3 is the left one. That's right. 8/3 being 2 and a bit. So that's that first part done. And then part B says, give full details of the two transformations needed to go from here to here. That's interesting, because, and the reason why I think it's interesting is because normally it's y equals mod x, or you get the same thing, but here I'm starting with y equals mod x minus 2, which I've already said is there. So I suppose I've already said as well that even though it looks as if that should be first and that should be second, because it's in the bracket, which is effectively what the modular sign is, I've got to do this one first. So the very first thing I've got to do is go from minus 2 to minus 6. I reckon that's a translation by 4, 0. I move it 4 across. And then I make it steeper by doing that 2. That will effectively be a stretch. It's in the bracket, so it's the wrong way around. Stretch parallel to the x-axis. A scale factor of 1/2. Yeah, I haven't got the answers. You have to take my word for it. Next question then. So what does this say? We've got, this is an old core 3 exam, so this is going back a bit. The diagram shows y equals ek to the x minus a. So this is y equals ek to the x minus a. So it's what presumably was at some time like that. That was e to the x. They stretched it in some way and then moved it down. Give the details of a pair of transformations which transforms it. Yeah, so that's what I was really hinting at. This is y equals e to the x. I didn't even know that was coming, but there you are. So just think to yourself, which one's, this one's going to be a left and right. It's actually a stretch parallel to the x-axis by a scale factor of 1 over k. But this one's up and down, so it means I can do them in either order. So I'm going to do that. I'm going to say this one first. I'm going to say it's a stretch parallel to the x-axis. It's like it's in a bracket, you see. Scale factor 1 over k, and followed by a translation. And it goes down, so presumably 0 minus a. Either way around, doesn't matter. Sketch the curve of this. All right, it's the modulus of, it's the modulus of what they've given me initially. So they've given me initially, it does this. What would the modulus do? Well, it's all around it. It's not individually around the x. So what it does is it reflects that bit upwards. I think it looks something like that. Okay, so what was going down has now been reflected upwards. Given that the curve, this one I've just done, passes through the points 0, 13, well they're telling me that's 0, 13 then. Okay, it's at 13. And also log 3, 13. Alright, so there's another point over there, same height, so that's log 3, 13. Find the values of k and a. Okay then, so I've got this equation, y equals the modulus of e to the kx minus a, and they're saying when x equals 0, it's 13. Y equals 13. So I'll substitute that in. 13 equals the modulus. Now, e to the 0 is 1. And effectively that gets, that's a modulus sign. So therefore, 1 minus a equals 13, or 1 minus a equals minus 13. If this is true, then a would have to equal 1 minus a minus 12. That would do the job. Or a equals, if I move it over and move it over, a equals 14. My suspicion is you meant to say that a equals 14 because it has definitely moved down. So therefore I think I can safely say that a equals 14. It'd be interesting to see the actual. It doesn't hint here that there's more than one version of a, so I'm going to say a equals 14. And then given that that is true, I can then put the log 3 into this as well when x is log 3. So y equals 13 again when x equals log 3. And so this, chucking it all into here again, 13 equals the modulus of e to the kx. Now we've got to be a little bit careful. E to the k log 3 minus the a, which I've already got, is 14. Might be better if I start this. I'm going to rub out some stuff here just so that we can see what we're going. Just to create a bit of space so that it's not quite so confusing what's going on. Still pretty bad, but there you go. Okay. So what are we doing now? Well, that means, well, I suppose I've got to do a little bit of something here. What is e to the k log 3? Well, times in is where you go e to the k, and you should recall that when you do these and they're times by each other, that means it's to like that. Nearly got it wrong then. So I can rewrite that as e to the log 3 to the k, and that's the same as 3 to the k. So that's interesting. So that tells me that 13 equals the modulus of 3 to the k minus 14. So 3 to the k minus 14 is either equal to 13 or 3 to the k minus 14 equals 13. 3 to the k equals 27. That gives me such a nice answer. It tells me 14 was right. K equals 3. And if I try to do this, I get 3. That's minus 13. I get 3 to the k equals, well, minus 14 over gives me 1. And therefore, what k would have to be equal to 0. And I don't think that's going to give me a proper answer either. So I think the answer is k is 3 and a is 14. I've got the answer in this one, so it worked. So here's another question. We're not going to do many. We're going to then leave you to it. So we've got y equals log x is transformed to y equals this. Give full details of the translation and stretch involved. Well, the translation, which is going to come first, is by a is 0. And the stretch is going to be a scale factor of 2, obviously parallel to the x-axis, because it's in the brackets. Sketch the graph of this. Okay, well, normally a log graph will look like that. And what am I doing? I've moved it further over and I've stretched it. So presumably this is still going to look something like that. But this point is no longer 1. That's all I would say on that. Do they want us to say? I'm not sure if they want us to say what this point is. They might do. What would the graph of the y equals the log of the same thing but modded look like? Well, that graph would be the same. It would look like that, but where it hits then it bounces back. Does that do? No, I haven't done that. That's misdrawn that bit there. Let me just rub that bit out. What would happen is it would normally, where's my pen gone? It's over here. It would normally do that, so presumably it would go like that and get closer and closer without ever touching. So something like that. And state in terms of a, the set of values for which this equals this. Well, the only way to really do this is to go log of the half x minus a is equal to this. Oh, it's very similar, isn't it? Or, of course, it could be the positive version. Now, if it's the positive version, not much happens really. Are they really saying, I'm just wondering if I'm meant to not try to solve it like this. They're saying, when does this graph equal this graph? And I actually think all the way along there, those two graphs are the same. And I think that's really what I'm meant to say. The one thing I haven't yet worked out is where that point is. I'm going to do it now. So when does all of this hit the 0 line? The 0 line. So when is y equal to 0? So I'm going to write 0 equals the log of a half x minus a. And move the log on the other side. E to the 0 is a half x minus a. And therefore that's 1. Move the a over, 1 plus a equals a half x. And therefore x equals double it to 2 plus 2a. So at least now I know that this point here is 2 plus 2a. I can get credit for that if they were looking for it. So what are they after in this last part? I'm nearly out of time, so I may not get a chance to do this. I've got to say when the modulus graph, which is this one, is the same as, it's got a minus in there, so it's the same as the opposite. I actually think it's only one value. Well, I think, no, it's that and that. So I think this last part is x is less than 2 plus 2a. And as long as, or equal to it, and as long as it's less than it to it, I think those two graphs coincide. So have I got an answer? Nearly. I haven't quite finished it, but there you go. So I'm just going to quickly move on. You've got to do this mixed practice, and best of luck with that.